let's see some examples of testing and writing methods that can throw unchecked exceptions. Okay? So let's say we're writing this method called average that computes the rounded average of an array of numbers. Okay? And by rounded, I just mean that it rounded down. Okay? So let's see. So, we just compute the average by taking the sum of the integers in the list and then divides it by the length. And then we have some test cases here. This should be the average, so 1 plus 2 plus 3 plus 4 plus 5. That is, let's see, that's 15. 15 divided by 5 is 3. And then this is the test case that matters, right? Because if we try to divide by 0, we're going to get an arithmetic exception, and we will divide by 0. Okay? So the question is, what do we want to do to prevent this? Well, we could do a few things. Up until now, we may have done something like, if ls.length is equal to 0, return 0, or something like that. But the problem is that a list could have an average of 0. For example, let's have this test case here where we have -2, 0, and 2. Or -2, 2, 0, for example. Or even just like -2 and 2. We can do that. The average of these is, well, actually no, that's not that. So this would be actually no, this wouldn't be 0. Let's see. Let me think of one that could be 0. Okay, I don't know why I was tweaking there. Yeah, this would be 0 because it's -2 plus 2 plus 0. That's 0 divided by 3 is 0. I don't know why I wasn't thinking straight there. Okay, so yeah, the average of a data set could be 0. Okay, so that's why this can be problematic, because you're saying that an empty array's average is 0, but 0 could be a valid number. You're sort of saying that 0 is both a valid and an invalid number with this return. So you may think, okay, well, what if we wrap it inside of an optional? We could do that. But there's another way that also works, and both have their, using optionals versus this other approach, they both have their pros and cons, okay? What we could also do is just throw a new, let's see, then we have a bunch of different exception types that we can throw. So, for example, we can say throw new illegal argument exception, array is empty. Okay, array is empty. So you could do something like that, or you could also do like a no such element exception. Or as you'll see in the next video, we can also write our own type of exception. So what this will do is Java will say, okay, or our program will say, if the array length is 0, we're going to throw this exception type and then just return control to whatever is handling the exception. In this case, what's handling the exception is this assert equals call. Okay? So let's run this now and let's see what happens. It's going to do the same thing, but it's just going to say this time, instead of doing a division by 0, we're going to say that the array is empty. Okay? Now, how do we check to see that this actually does what we want to do? Okay, because in order for this to be comprehensive, we need to write a test case that says, does this input cause an exception to be thrown? And indeed, we can do that. There's a method called assert throws, and the way this works is a little bit weird, so just bear with me for a minute. The first argument is the type of exception that is being thrown. In this case, it's an illegal argument exception, but we can't just pass illegal argument exception. We have to say that it throws the illegal argument exception class. So you put .class after it. Okay? The next thing we do is we have to wrap the second argument inside of a lambda expression. Okay? I don't know why IntelliJ is... There we go. We have to wrap the second argument inside of a lambda. Now, why is that? The reason why is because remember how Java evaluates its arguments. If we don't put this inside of a lambda, then Java will immediately evaluate this expression and it will throw the exception before assert throws can go, okay, is this code going to throw an exception? I'm looking out for the fact that it could throw that exception now. Okay? So if we don't put it inside of a lambda, the evaluation is not delayed. By putting it under a lambda, it's saying, okay, here is effectively a function, that functional interface, and then assert throws is going to say, all right, I now know that this is going to throw or could throw an illegal argument exception. Now you can run and go. Okay? So you have to put the argument to assert throws under a lambda expression, or else it will not work. It won't compile. Okay? So what about the opposite? Well, we can also do assert does not throw. Okay? So for example, this test case should not throw an exception. Okay? This is just the dual to assert throws. And again, this one also receives a lambda expression. Okay? But you should note that this assert does not throw doesn't allow you to check whether something returns a value, because you have to give it a lambda expression. Okay? Let's run these and see what happens now. Okay. Well, actually, so in this case, I've been doing it wrong this whole time. We put this one, we should flip these, right? Because this one doesn't need to throw an exception. Okay? So, that was silly. So let's do assert equals, and then we'll make this one assert throws. This is the one that we care about. Okay, and this one's actually 0. The result for this one is actually 0. Okay? So let's run it, and now everything should work as we expect. Okay? So in this video, I showed you how to throw an unchecked exception, and then account for that exception when you're writing test cases.